In question 1, we are looking at radioactive decay, and we are given this function here, which enables us to find the mass in grams of radioactive material after t years. So initially, what was the original mass of the radioactive material? So from that, we need to deduce, whenever it says original or initial, that means that the time was 0. So we're going to take t equals 0 and substitute that into this equation. So 90 multiplied by 2 to the power negative 0 over 20. Well, 0 over 20 is going to be 0. Anything to the power 0 is 1. So we should remember that anything to the power 0 is equal to 1. So therefore, this is just going to be 90 times 1, which is 90. In part B, find the value of V in this table here. So they're saying what's the mass after 80 years. 80 years. So you're going to take that and substitute that into the function. So you're going to do 90 times 2 to the power negative 80 over 20. And if you substitute that into your calculator, you will end up with 5.625 grams, or 5.63 to 3 sig fig. For part C then, this is the tricky bit. Calculate the number of years it would take for the radioactive material to have a mass of 45 grams. So in effect here, if you know what the mass is, so the mass we're saying is 45, and we're being asked to find how long it takes. So we're being asked to find the value t, which is an exponent. So there's two ways that you could do this. You could either do it graphically. So on your calculator, you could put y equals 45 as your first function, and your second function, you could put y is equal to 90 multiplied by 2 to the power negative x over 20. The easiest way of doing it is going to be on the n solver. So on your TI Inspire, if you go to maths and then you go up one, you'll have n solver with 2 boxes, and in the first box you're going to enter 45, and in the second box you're going to enter 90 times 2 to the power negative x over 20, and if you solve that you will end up with a value of 20 years.